I'm going to share my screen with everybody, and hopefully you will be able to see my presentation. So I'm just going to come up to here, slideshow. So can everyone see that?
Yes,
Yes, I can see that. Thank you.
Oh, that's great. I thought I got technical problems there. So yeah, so once again, thanks Amy for inviting me today. So realistically, what I wanted to talk to everyone about is about immersive experiences within education and training. Obviously, I've got 45 minutes to try and cover this, so I'm probably just scratching some of the surface, but hopefully you'll find this quite interesting in terms of where we're going with XR. So today I thought I would break this down into different areas about a little bit about the history of the technology for those that are not so familiar with XR and what XR is. There have been lots of things in the past few years regarding different acronyms, so I think it's quite good to know what XR is. I'd also want to touch upon things like the VR experiences, where VR fits into education, as well as AR and MR experiences. So obviously they're very different in some respects. The other is geolocation. So this is something I'm doing as part of my own research, because I think this is where it presents some really interesting opportunities for research and for learning, and also training as well. I think there's lots of different examples out there, I have to say, in these last 3 or 4 years where XR or MR has been really kind of helping to train people. And also the future. So what does the future hold? Where are we going with all of this? And where is the technology taking us? So just a bit of history about me, about myself, and also about XR. So I work at York St John University. I'm program leader for VR and AR and designing technologies. But I originally started out with Alias Wavefront, working for them, using some of their 3D technology, Power Studio, Power Animator, many years ago. And I went to work for the BBC using virtual reality for set design, for things like motion capture with Protozoa. And I also worked with the BBC's 3D animation and effects department. So I was working on different projects and different TV shows. Worked as a creative director for 8 years as well in my own company, and I also sat on the Autodesk secondary education board just to advise them in terms of some of the 3D curriculum. I'm currently undertaking a PhD in AR for primary science education at York University as well. So I've won quite a number of awards, been nominated for a number of awards as well in my time. So that's a little bit about me. So just to kind of kickstart things off with mounted headsets and where they kind of started, or I wouldn't say originated, but where they kind of started. So with Sutherland and ATEL, they created the Sword of Damocles, which was the first experimentation with head-mounted displays. Obviously, you can see that they look quite heavy. The title is kind of explaining, in some senses, that this huge thing above a person, like a sword, could easily fall on top of somebody. So It's quite crude, but in effect, for 1968, it's something which actually was quite unique and exceptional for its time. And then obviously people like NASA, they started to get involved in using VR. And as you can see, once again, there's lots of wires, there's lots of equipment surrounding somebody whilst they're in a virtual environment. So, you know, things weren't as easy as many years ago. Then we moved to things like Play, which was virtuality, which was founded by Jonathan Walden as part of a PhD graduate from Loughborough. So we got these kind of things where we were starting to work with or play with VR as well. So things started becoming quite interesting during those times. And in 1994, Milgram and Cascino, they kind of came up with the continuum, which slightly explained a diagram in terms of real and virtual environments, and the in between there was what we call today as being mixed reality. So that was back in 1994. And during the times when I was working at Alias, we used these silicon graphics, we used these machines, Indigo. They were something like 256 meg. Today is just, you know, it's small fry. So these are the types of machines I was working on. And I was working in 1998 on the first children's TV interactive program, which was Banzuki, which I worked with Dr. Richard Hawkes from Hewlett Packard and Professor Graham Thomas. And this was based on Carl Sims' work, where we were looking at actually bringing and allowing kids to create their own characters from home, and then those characters would be selected to fight against each other. So it was kind of, I suppose, in a way, Robot Wars meets virtual reality back in 1998. And 1999, we had Cato and Billinghurst, who actually devised the AR toolkit. So using markers, it would trigger a 3D kind of source in front of somebody so they could see a 3D object or an animation to appear. So, you know, things were starting to move along just in the late 1990s. And these are marker patterns. So the marker patterns, if you're not familiar with them, they triggered certain 3D kind of animations or 3D objects. So that's in 2011, I started working with Autodesk because I was really fascinated with AR, and we ran a small project where I created a number of characters for the periodic table. And what would happen is we rolled this out to US schools and to UK schools in terms of learning about chemistry and animation and 3D modeling. But also what would happen is the kids could literally put a phone up to the marker and it would trigger a character to appear and would speak to the audience and say, I'm Argon, I'm this, I represent this. So we were kind of like playing around with it during those years, but it was still slightly crude, and also people weren't really kind of familiar with AR and adopting it. It wasn't something which, you know, it was part and parcel, integral to, you know, social communities. 2014, I worked on the next project, which was looking at the campus, so York St John campus, and we created some markers which parents and students could walk up to. They could put their phone up to these markers, and a YSJ character would appear and talk to them about where they were, what they could do, how they could kind of use the phone to interact. And it was something, something different, something that we trialed, and we planted these all around the campus themselves, and it worked quite effectively. So we were quite proud of that, and also it's a really good student project, I have to say. So when we start to look at these different types of realities, I remember when I first started out, it was, everyone was talking about AR, augmented reality, and then obviously there was virtual reality, and then people started to mention mixed reality. It's like, okay, mixed reality, augmented, virtual, and it all became kind of like, oh, right, what are all these things? What are all these things going off? And I think so you kind of put everything under one umbrella. We now call everything under one umbrella as being extended reality. So when we talk about XR, or if we hear the word or the terminology, should I say, XR, it represents extended realities, which encompass AR, MR, and VR. And when we look at AR, AR is something where technology or graphics is overlaid onto the real world. The mixed reality is where we're merging the real world and the digital world together, so you've got more of a tracking basis on that. And the virtual reality is obviously where you're completely immersed in one environment, and you're totally devoid from the real world. So that's just hopefully something. And when we obviously start to look at these, there are different ways and different kind of platforms out there. I mean, a lot of people with AR are familiar with Pokemon. When you're playing Pokemon, which was very well received a few years ago. And then we've got mixed reality, where Microsoft and the Hololens, they kind of coined the phrase mixed reality. And then we've obviously got virtual reality, where we've got now the Oculus Quest, Hive, etc. So, and I think also when we look at these immersive experiences, there are obviously two platforms: the mobile platform and the wearable platforms as well, which I can come on to. So the other thing just to mention as well with the handheld AR is things like we've got the marker based, and then we've got markerless, so we don't need markers to trigger animations, information on our devices. This is just something which has just come out from Zappa, which I've in some ways helped fund, but this is the new kind of marker base for Zappa, where they're trying to democratize education. So, but this is obviously using marker-based products. So what does this mean for education? So what does it mean in terms of we've got all these experiences? How does this kind of fit into education, and what can we learn from it, and how can schools or colleges or whatever learn from it as well? So that's a good start. So in some ways, I'll just do that again. In some ways, we have, probably quite a number of us are familiar with Google expeditions. So these were things obviously where VR can be used within classes. Children can put the VR headsets up to them. They can go on field trips. They can travel around the world, and they can explore things together as well. I think what's interesting about that as well is the inclusiveness. So no matter what background you're from or social background, you can all travel together on this journey in terms of doing it. And also Google have announced that due to COVID and people working remotely, that they're migrating this onto the arts and culture app, so everyone can use it and work with it. I think that's video. I'll just move on. And then we've got other companies like ClassVR. So when I went to the BET show for the education show, you have ClassVR, you have other companies there, and what they're now doing is rolling out these kind of kits into schools where they can have these portable sets which charge. They then can select, or the teachers can select different topics, and then they can obviously deliver this to the class. So the ClassVR is it's quite popular with the number of schools, and it's another form of actually kind of describing or getting children to interact with different subject areas and disciplines, which is quite interesting. I think everyone's kind of familiar now, or maybe familiar now, with the Oculus Quest 2. So obviously Facebook are really kind of invested in this area. The Oculus Quest 2 is untethered, so there are no wires anymore. You don't have to. You're not restricted in terms of movement, in terms of performance as well. They're pretty good on performance. There are some good graphics that come from that, and I wouldn't say they're cheap in any way, but they are becoming slightly more affordable as well, and you get more kind of bang for your buck. And Facebook are, they're kind of seeing this kind of new territory, the way that we communicate and the way that we kind of immerse ourselves is something that obviously they're really keen on. I don't know if anyone remembers this, but I used to go on to Second Life many years ago, and you could interact with people, you could talk to different people, you could even buy different kind of 3D clothes. And I know a lot of people, quite a number of people actually got quite rich doing that by selling different items of clothing on there and building real estate. But this is kind of, in some ways, I remember this being a first way of interacting virtually with other people from everywhere and anywhere, and it was quite interesting times. And the same way now, when you look at the Oculus Quest and you look at a company called Spatial, what they're doing now is they're kind of looking at the space, the remote learning space, and how we may be, well, not may, but how we can possibly teach in different ways, in different environments. And I think also, with COVID happening, it's kind of exasperated, and it's actually, in some ways, it's forced teachers to look at ways that we can remotely interact and teach. So I'm just going to play this video, so hopefully it works.
It used to be that if you really wanted to jam on an idea or get creative, you'd get in a room with someone, even to the extent that you take a flight to do that. With Spatial, with AR and VR, we can put on a headset, and even if we're not in the same room as someone, we can feel like we are. From a simple 2D photo, you get a super realistic avatar. You can create these project rooms, kind of like a 3D version of Zoom meets Slack. Pull up all the kind of traditional content that you're used to, organize your thoughts. Spatial gives you like a visual, virtual way to bring all that together. Oculus is investing so heavily just across every layer of the stack, whether it's the development, the hardware, the outreach. They're loaning devices to companies who are VR curious, and I think they understand what kind of features developers want. Now we can enrich our app with hand tracking. I mean, I love the simplicity of just the headset in your hands. There's an opportunity with this new wave to like get in there early, put our humanistic ideals into the technology so that it can be creative and collaborative and bring us closer together.
So I think just by watching that, you can get a sense of actually how you may perhaps reform or explore ways of teaching or interacting or collaborating, as they quite rightly said, using these technologies. So some of the things that I've been looking at, I've been focusing more on the science aspects of things. But when we look at the interaction or the way that we can teach people or educate people within virtual environments, there are things like VR labs, like the HoloLab, Mel Science and Labster. So with the HoloLab, they play quizzes. You can interact with virtual objects. You can make experiments, create experiments. So there are kind of like new ways that we can interact and involve children or students remotely in terms of learning about certain processes. And I think this kind of offers new opportunities once again for everyone in terms of looking at their teaching deliveries, but also looking at their subject areas and thinking, well, actually, is there kind of a connection there in terms of the way that we can teach? And also, I think the one thing that I have been noticing is resources as well. When we have to buy resources, the interesting thing about virtual reality is when you make a virtual object, it's constantly there. It's there. So you just kind of need the software to kind of make things and create things. And generally, a lot of the software now today is freely available to all education. When you look at Autodesk, Unreal, Unity, they're pretty much all freely available. So this doesn't come at a cost. It just comes at what can you really create. And then when you kind of start to look at other things as well in VR, there's the Hands Physics Lab, which I was doing some research on, where you can use hand tracking to kind of create things, make things. So once again, that kind of interactivity and the use of haptics really kind of starts to create environments which become and feel much more realistic, and this will only get better as time moves on with the technology. It will only improve and get better. So these are types of things that are interesting. This recently came out at the beginning of this month, and I thought it was something just to show you, but this is some of the Facebook reality labs, and this is hand tracking. So you can start to see, how quickly the technology is moving, but how kind of advanced it's becoming now as well. So, some of the hand tracking systems are just pretty impressive. So when we start to look at this and we start to think about us being in virtual environments, I would say this kind of really offers lots of different opportunities for us and for learning and making. And Facebook are doing a lot of work on this, so what I would say, Facebook are kind of really moving in this direction. For a company to do that, I think they obviously know and see the opportunities for this as well. So I'll just move on. So the other thing is what's been quite interesting is tangible AR. So some of the things that have been in the development process are things like Merge, and Merge is a tangible cube which students can use within a classroom, and what they can do is they can move it, they can interact with it, and AR will actually appear on top of the cube, so you can move it and shift it and you can move around with it. So you've got that kind of interactiveness. I'm just going to try and play. Got a bit of a technical problem. Hopefully, just 1 second. Sorry. Something happened there.
Teaching aids have been around forever. Teaching aids have been around forever because students learn better when they can hold. Teaching aids have been around forever because students. Teaching aids have been around forever because students learn better when they can hold and inspect physical objects. These days,
I think I'll just have to move on with that one because the video is not working. But what I would say is the merge cube. When you look at it, if you take a look at it, you'll see that the way that the students can interact with it and can handle this cube and it move objects, 3D objects. Lots of things there, good for STEM learning, good for science, etc. So, and it's just another way of introducing AR into the classroom. And then we can moving on to something called Augmented Creativity. So this is from some nurse from the Disney research. The Disney research have been doing lots of kind of explorations into AR and the way that it can work, but also the way that we can interact with AR and things for education or the way that music, perhaps as a subject area, can benefit from using different kind of AR methods. So the one thing that he's been doing with a lot of other academics is looking at kind of colouring books, so interactive UV texture mapping in real time, looking at experimenting with music in terms of bringing different objects onto the screen with different music, and they then interact and create different sounds. So I'll just play this for you. Hopefully it will work.
Augmented reality is the concept where we blend digital objects and digital characters seamlessly into the real world around us. There's a huge potential in augmented reality to impact so many aspects of our lives. And when you think about it, there's a very powerful concept of taking the natural interaction of the real world and combining it with all the power that comes from digital tools and digital devices. Because augmented reality has such a holistic potential impact, Disney Research is taking a holistic approach to our research in this space. Everything across the entire pipeline of augmented reality creation and consumption is part of our strategic research mission. We're exploring everything from novel display technology to new forms of digital storytelling and interaction that's enabled by augmented reality.
So I suppose that just gives you kind of a flavour of what they're doing. I mean, some of this is a year or a few years old, but you can start to see, you know, what kind of potential AR has in terms of kind of creating new content for students to interact with. So the other thing when we start to talk about wearables as well, HoloLens, so the Microsoft HoloLens, which we've been using and looking at and exploring, offers obviously wearable technology in terms of overlaying 3D onto real environments. And companies like Lifelike they've been doing quite a lot of kind of content for students in terms of K-12 and even prep schools, astonishingly. But the things that they kind of started to find within their research is obviously things like 75.9% of their students felt the lesson captured their attention more. And this is kind of things that are a common thread about engagement with students in terms of engagement when using this technology. And also 69% were motivated, more time to learn. So students have more time to learn at their own pace as well, which is quite interesting in terms of doing things remotely and reflecting on the type of learning or experiential learning that's taking place. And sometimes more curious. They put 78.3% are more curious. So there are kind of lots of different statistics within that. But I would say that obviously companies like Pearson, who we all know are a predominant educational company, have been kind of working with the HoloLens as well in terms of helping to teach new or different subject areas. And they see this as being something which may be the new library, where students can go into a library, put one of their headsets on, and just kind of interact and learn about new kind of subjects or gather new knowledge. And there is obviously the HoloLens 2, which has been released. So this once again, this technology is moving quite fast, at a fast pace, and it's only getting better in some respect. So when we start to also look at the technology itself, I think it's quite interesting to think about what it provides in some ways. So in terms of cognitive process, it enables students to practice and perfect skills in a safe environment in some way. So once again, you may be, if you're doing chemistry or other activities. It also focuses, there's evidence to show from Microsoft that it focuses the kind of students' attention, which then improves their kind of abilities. And the cognitive load for mixed reality reduces information bottlenecks and increases performance. So a kind of few things in the cognitive process. Although saying that, these are obviously statistics from certain sources, and we do have to be mindful that there is a fine balance between what AR and MR and VR can do, but we have to obviously look at some of the kind of obstacles as well, which I will come to. The emotional learning as well. So obviously with immersive technologies, we can try and democratize education. And I think with mixed reality as well, it offers a new form of collaboration for both mixed reality and AR and VR, and diversity as well. So quite a number of our projects that students do undertake, especially with immersive technologies, it allows you to kind of experience things from perspective of others, and it actually, there's a lot of empathy. It gives you more empathy in terms of your kind of understanding and projects, and behavior as well. In terms of simulations allow learners to recreate and practice situations. So once again, that comes down to training as well, which I'll move on to. But you can practice situations, you can recreate situations, and some of our students are also working in terms of consent. So VR is good in terms of helping people to be in a situation, in a virtual situation. So there are a lot of benefits there. Identity as well. So when we look at immersive experiences, there's been reports about higher level engagement with issues such as homelessness and environment. some of our students have been working on the plastics within the ocean, especially balloons, and actually putting people into VR situations to kind of just highlight the plight of what's going on. And then situated learning as well. So immersive technologies can increase rates of skills transfer, enabling students to apply theoretical concepts. So, you know, the situated learning is once again another kind of highlight for behaviour. Which brings me on to, I just thought about some of the research that I've been doing and undertaking. So I've been awarded an EPIC mega grant to look at remote science. So sorry, to analyse remote learning, but with this specific science learning for primary schools. And this was before COVID happened, but I've been extremely interested in how the technology can help children or students to learn from remote situations. I think this offers some really interesting, the technology offers some really interesting kind of opportunities for all of us. And I think it's particularly in geolocation. So when we talk about geolocation, we talk about how, you know, anyone can be situated within a space or an area, and they can be receiving data or uploading data, transferring data. And in some ways, for me, that offers a lot of good opportunities in terms of 5G connectivity. So when we do talk about things like the Internet of Things, wearable devices, 5G connectivity really starts to offer learning in a different kind of different manner, in a different way. So whether a child is out in a playground or at home, they could potentially have this kind of learning experience using AR, augmented reality or mixed reality. And you know, the technology and the connectivity is there to do that now. So when we start to look at this, we start to look at things like Google, so AR Core with their depth API systems, where they can create depth maps. So essentially, what we can do, what the devices can do now, is they can read depth maps, they can look at depth maps, they can see what's in front of us and what's behind us. So obviously, this is like really interesting in terms of the way that we integrate 3D into real environments. So I'll just play this so it gives you, and it contextualizes the way that they're looking at the technology to blend AR into real environments.
We're used to AR at our fingertips, giving us useful and fun experiences. Your content, though, often looks like it's pasted on the screen rather than in the world. What if AR Core could supercharge your camera, bringing the world into your phone by giving you color and depth at every pixel that it sees? We've squeezed all of our software magic into the new AR Core Depth API, so that with just a single moving camera, we can give you 3D understanding of the world on over 200 million Android phones. This means that we can start properly occluding objects like our 3D tiger.
But occlusions are just one aspect of immersive AR experiences. When your camera understands 3D space, your content can realistically collide with the world, or even just stick to it instead of bouncing around. And your characters can move around your space naturally on any terrain. Or you can transform the world around your users by using particle-based effects, such as snow piling up in your surroundings, or splashing rain, basically blending the real and the virtual. And if your phone has an active depth sensor, all of these depth-based effects can get even better.
It's all about, trying to pull in as much information from the real world into your digital world so that you can really help these augmented objects feel grounded in the real world. You're looking at things like light estimation, environmental HDR, and now I see depth as just kind of one additional layer to really have those objects feel like they exist in the real world.
With Houses View in My Room feature, we want to help people make much more confident buying decisions by letting them preview products in their own space before they make the purchase. Google's solving a really, really challenging technical problem here. And the greatest part of it is that it's actually available to a really wide range of Android phones without any specialized hardware. So it really is something that we can bring to mass market to help people have a much better preview experience.
We partner with the studio MediaMarks to explore how we could turn your physical environment into a creative canvas with depth. By better understanding your physical space, we're able to really turn it into a new world, into a different dimension, allowing us to hide characters behind objects and furniture, enabling new types of interaction, even being able to paint what's around you thanks to augmented reality.
If we really look at what a Unity developer to combine with the AR core technology for depth can do is you drag in a component, you easily pull in that data, and you start easily make sense out of it and also have it combined with all the other systems in Unity. If it's particle systems, or if it's navigation meshes for characters, or it's just occlusion to make sure that things blend in well. Those are the core pieces that we, together with Google, make easy and accessible for Unity developers.
And we need developers like you to help us build the future. These experiences are just scratching the surface of what's possible with depth. If you have an idea that you'd like to build using the Depth API, fill out our Call for Collaborators form in the description below. We're looking for a few more developers over 2020 to help us build out a new wave of AR experiences. Thank you so much for joining us. We can't wait to see what you build with the AR Core Depth API.
So I think with that, obviously there's so much room for career choices for developers. There are so many kind of ideas in terms of gaming, interactions with learning as well. So, it presents some really interesting opportunities. When we look at some of the AR kits, so this is the Apple, they have obviously introduced something called the LiDAR, so the light detecting and ranging. And what's interesting about this is, in terms of your phone, you can create 3D objects very, very quickly, scan them in. It's like scanning an object. So just as a very short demo, you can see someone's scanned their dog in, and they're now going to place their second dog next to that. And obviously this is not it's not perfect in any form or shape, but it just, once again, it presents opportunities and to think about actually using 3D objects to teach or to learn or to scan with some of this technology. It's easy to use, it's not complicated as well, which I think is really important for the end user. So I'll just move on from that. So some of the things that I've discovered, and there's a lot more in terms of the research, is about adoption for schools or education. So some teachers, some people are educators are a little bit kind of wary about using new tech, and for good reasons as well, in terms of, will the tech be, will it work properly? Will there be any complications? Is it ease of use? And I think a lot of teachers have explained that they want really CPD training before they start to adopt it. And affordability, I think affordability is a real key thing for any education establishment, that if you're going to use this tech, it can't be expensive, and some of the wearable technology is expensive out there, but obviously I think these things will come down in price and only get better as time moves on. But the great things about it is I pointed out earlier is engagement, is active learning, is sharing experiences and students be able to work at a certain pace. And also the parental engagement as well. I think that's really important for, especially for science capital, the way that parents can get involved at home with their children to kind of interact and engage with learning experiences. But we have to be mindful of, you know, there's different ethical implications here with safeguarding, with wearable technology for young children. There are certain things that there are challenges and barriers. So, but a lot more of that is in the paper that I'm going to be releasing early next year. So in terms of training, just moving on, I went to an Autodesk convention a few years ago actually, and what was interesting is Skanska was talking about how they'd used a building information model in BIM, and they'd used that in an AR experience to kind of train their staff, but also to kind of overlay 3D models where they were constructing things and making things. And now, you know, they've adopted this kind of technology. It's moving quite quickly. A lot of other companies are. So in terms of training, in terms of education as well, the construction industry, there are lots of avenues for this, for using immersive experiences. So, and you know, Autodesk, in terms of their BIM and Revit 3D models, they've imported things into AR and VR, which is great because you can see that kind of seamlessness, and you can also see the pipeline of how companies now are working differently in terms of production. So the PwC also did some studies about corporate training, about also the benefits of VR, and I thought this was quite interesting about what they discovered is a higher retention rate, higher engagement rate, safe for high risk situations, and reduced training and travel expenses. 275% more confident to act on what they'd learnt, 4 times faster than classroom training on average. So there's lots of things within this in terms of using VR to kind of train staff, which some colleges might want to kind of look at and invest in as part of their kind of curriculum activities. And you know, when we start to see how companies are using this technology, like 3D Repo for Balfour, BT, and the highways using virtual simulations for health and safety training, we start to look at the kind of production or the product developers using Gravity Sketch to mock up new kind of car mock-ups and models and designing through different flow works. This kind of, you know, whether we're not familiar with this yet, but this will start to change our workflow and how production operates in different ways. And once again, healthcare as well. There's numerous, especially with the HoloLens, there's been numerous kind of studies in terms of doctors using HoloLens to overlay 3D anatomical information, to kind of train surgeons as well. So there are other ways of and forms of training staff. So in terms of the future as well, it gets very interesting because there's I don't know if there's a futurist called Kisha Matsuda, which I've shown my students, and he created a film called Hyper Reality, which gives you a very kind of sense of how the future might hold in terms of this kind of technology as we move through our day-to-day lives. I will just play a bit of this, but you get a sense of
Fantastic. Pregúntate si quieres una buena calificación.
Voy lo más rápido que puedo.
¿Has pensado en correr? Es saludable y eficiente.
Seguro que no hay más trabajos disponibles. Yo estudié para ser profesora y estoy haciendo mercados.
Y además puedes quedarte con los puntos de fidelización. Eres una monje afortunada. Tienes que confiar en la aplicación. ¿Te sientes inspirada? Gracias. Chao.
¿Quién soy yo? No, eso no es lo que quiero.
So I won't play it all, but you get a sense. If you watch it, it's really intriguing. But obviously, there is slight kind of cognitive overload with that, in a sense. So the other things that are starting to develop is a new headset called CognitionOne, where this actually headset reads a person's brain in terms of its communication. So this has been recently developed, but once again, on a really positive kind of perspective, this will help people with certain communication disorders such as cerebral palsy to kind of communicate more effectively. And I can imagine that as the future starts to move, we'll see more of this kind of integration of these devices working and integrating with humans in terms of how we communicate, and also kind of how they can read our thoughts, and which is slightly scary, but it's starting to move that way. There's also contact lenses, so AR contact lenses, which are being developed. So instead of wearing these kind of bulky headsets, there are kind of developments and exploration to make these kind of AR contact lenses. So these are things that have been developed. The thing to note, I think it's quite a good quote from Alex Kipman, who's a lead developer for Microsoft HoloLens, but he says arguing against a mixed reality future is difficult. At some point, it's easy to imagine a future where real-time information is piped into a wearable or even the brain itself, but there are going to be significant steps that lead us there, and today's bulky headsets are closer to a wobbly toddler than an awkward adolescent, and I would probably agree with that. But there are kind of books out there are kind of movements, the transhumanism movements, where they see technology integrating into the human form, and the way that this could be the next form of evolution for the human race. So I think there's lots of interesting things that are developing out there, from bioprinting, 3D printing, to us actually connecting ourselves to machines. And I think a really good book that I read a while back was To Be a Machine by Mark O'Connell. And then I suppose with Epic as well and Unreal, when you start to look at real-time graphics, this is real-time graphics, and I don't know if you've watched The Mandalorian, but that's all real-time as well. And you start to get a real sense of how 3D graphics starting to look so real. There will be that kind of, there won't be that differentiation between understanding what is real and what isn't. So I'll just play this. This is real-time ray tracing.
What's the story with all the elevators lately? I heard Kylo Ren destroyed the one over in D sector.
If you ask me, who's ever in charge of this place should be transferred to Hoth. What? What?
You think she heard us?
I think she heard us. At least we blend in for once.
So, so that was all real-time graphics. I think to make, which is incredible. I think lastly, what I would say is the one thing that, for me personally, as a designer, what I've been really focusing on is about creating and working with stakeholders and partnerships to develop effective AR applications. And in order to do that, I've been focusing on things like service design thinking, talking to the users and what they need really, and I think empathy is really important from my perspective in terms of creating some really effective AR or XR applications, and that's what I'm kind of doing throughout the next few years. So finally, just say thank you. My email address is there if you want to kind of ask any more questions, or feel free to ask me questions now, or drop me an email. And thanks for attending the session. Thank you very much.
Thanks, Warren. That was really interesting. And I think the comments on the chat also echo that. People found it really interesting, and it's interesting to see the future as well, where it's going, and a little bit scary sometimes as well, but some really good opportunities, I think, and particularly opportunities for education. So thanks for all attending, and thanks for Warren for delivering that.
Thank you. No problem. Cheers.
Thank you.
Thank you.